guys. So question 7 from the quiz on the pre-calculus part asks us if we know that at 50 miles per hour it takes 3.5 hours to get from Long Island to Albany. Answer the following 3 questions. 1. Is the relationship between speed and distance directly or inversely proportional? Find a formula for the relationship of time with respect to speed, and how many miles per hour would you need to drive to make it to Albany in 3 hours? So this first question doesn't even involve any math. It's just a question of understanding basic physics. If you imagine that you're driving along a highway and you've got 2 cars, one's going slow, we'll put that in blue, and one is going fast, we'll put that in red. Which one is going to get to the finish line first? Well, you would say the fast one's going to get there first. It has a greater velocity and its time ends up being smaller. Whereas this one has a smaller velocity, it's slower, and it takes longer to get there. Now this first question asks us, is the time the drive takes directly or inversely proportional to the speed? A proportion means that there's some relationship between these two values. And if it's a direct proportion, then that means that if you have some 2 values that you're relating, say, let's call them x and y, as x gets bigger, if y also gets bigger, that's called a direct proportion. But if as x gets bigger, y gets smaller, that's called an inverse proportion. So what we have when we talk about speed and distance here, as you can see, as speed gets bigger, the time it takes to get to the end is smaller, and vice versa, which means we're looking at an inverse proportion. So that's the answer to the first part of the question. Didn't involve any math, it just had involved thinking about what you know about what happens when you're moving faster or slower. So with that information, remember that in a proportion, let's say you have the proportion of speed and time, we'll call that speed equals something times time. The proportion implies that these aren't necessarily equal, but they change in the same way. So if t changes in a certain way, s has a predictable way that it's going to change. And that rate of change is this proportion, this mystery number. So if you're looking at a direct proportion, this value will be positive. But if you're looking at an inverse proportion, this value will be negative, because then as time gets bigger, this value will become more negative, so speed will get smaller. So we're looking at, just to review, that's what it would look like if we were writing up a proportion. So we have this proportion. We know it's an inverse proportion, and now they want us to figure out how to write out the function of time with respect to speed. Well, we can actually figure out what this proportion is because we have a time and a speed with which we can solve for the constant of proportionality. That's the value that tells you the proportion between speed and time. So let's call it k, this constant that we're looking for. We've got it's going to be multiplied by a speed v, which is going to end up in our equation, and we're setting it equal to h, and we want to find k. So if we plug in our value of time, 3.5 hours, and we plug in our velocity, we should be able to find k. And k is going to equal 3.5 over 50. So that's our k, 3.5 over 50. Now, the final question asks, if we want to get to Albany in 3 hours, how many miles per hour do we need to drive? Well, we can just plug these mystery values into our equation. We've got time, 3 hours, equals h of, I'm calling my mystery speed x. I could have just called it v, but I felt like changing it up. Mystery speed is x equals 3.5 over 50, and anytime I see this generic variable for velocity, I'm going to replace it with my mystery velocity, x. So now we just need to solve through. 3 equals 3.5 over 50, x. Multiply both sides by the reciprocal of our constant of proportionality. 50, if we do 50 over 3.5 times 3.5 over 50 times x, these two cancel each other out, and we're left with this as our speed. Thanks for listening.